been with Stiebel for about the last 10 years. He's known as a wealth of information in all things heat pumps and thermal comfort. Thermal comfort being your heating and cooling, heat recovery units, everything inside that building envelope. So let's go find Tom, find out a little bit more about what he's got to say. Good, shall we grab a coffee?
Absolutely, then we can head in town into the showroom.
All right. So Tom, where's the office?
Today we're heading over to Botany, where our Sydney showroom and an office sits, not our head office. Head office is in Port Melbourne.
So Stiebel, they've been around for how long? They're a big company, I've heard of them.
Originated in 1924, so we're almost up to our 100th birthday, but 25 years strong in Australia.
So they're European based, but operate here and in other countries? Any manufacturing in Australia?
No, not at this stage. Look, manufacturing is spread across various countries for various products, predominantly within the renewable space. Manufacturing is done at Holzminden in Germany, or Arvika in Sweden for our ground source heat pumps.
Mm-hmm. When we're looking at heat pumps, residential, they're fairly common. Commercial, maybe not so much, but what type of heat pumps are there out there?
Look, the general term of heat pump essentially relates to an air conditioner or an air-to-water system. Stiebel Eltron is a European manufacturer. We only do air-to-water and what they refer to as brine to water or water-to-water systems, more commonly known as geothermal. And that's predominantly what we offer in Australia today, so air-to-water and water-to-water systems.
Because the geothermal is all about using the ground as your source, correct?
Yeah, absolutely.
Yeah.
As opposed to the air source, so you have the advantages of lower winters and summers below ground.
Yeah, good. And again, in a commercial space, obviously we're looking at much larger loads. What sizes can you go up to with a heat pump?
Looking ground source, we can do up to about a 1.5 megawatts in a single cascade.
1.5 megawatt.
Absolutely. Oh, wow. The advantage there is that your condensing, evaporating is all done below ground. So in terms of plant room space, you can eke back a lot of that area. In terms of air to water, the largest cascades we can do is around about that 200 kilowatt mark. But spatially and airflow wise, it becomes a little bit prohibitive, particularly in retrofits.
So what 1.5 megawatts, what sort of building are we looking at for that? What size is that?
Look, anything from residential, commercial buildings, office buildings, education, government buildings.
So a good school or a uni building?
Yeah, absolutely. Absolutely. Our largest job to date in Australia sits around that 300 kilowatt mark in Melbourne, which is a student accommodation building.
Okay. When we're looking at heat pumps, we're talking about purely electric systems.
Correct.
So the benefit of that, or why are we really focused on that in reference to our talk today on, what's the future look like in 10 years' time or more?
Look, the adoption of heat pump technology in Australia is coming on leaps and bounds in the last few years. It's only going to improve as we start to electrify buildings and aim for more efficient solutions in the marketplace. The important thing and the critical thing for the membership of CIBSE is that the expectations of what a heat pump can do and the application of utilising the right system, the right refrigerant within the right application ranges. So essentially designing the building around the heating and cooling system.
And refrigerant-wise, what are the systems? What type of refrigerants are used by Stiebel, or what's the ones that are out there, and how are they going to change? Because there's a lot of movement in that space.
There is, absolutely. So we're conventional refrigerants at the moment with R410A and R134A and R407C. Obviously the big push in Europe at the moment is a bit of an arms race to move to lower GWP refrigerants. Stiebel is moving down the path of R454C with an aim to be EU compliant by 2050, or in 2050. But the big push really is ensuring that by 2030 we're sitting below a GWP of 500.
Okay, and that's relevant to the Australian market? What's happening in the EU, or we're a little bit behind?
Look, I think we'll be guided somewhat by activities in the big manufacturing areas of Asia and Europe particularly. It's a bit of a ripple effect, I think, and we'll naturally feel the ripples.
Yeah.
But in terms of what we're doing locally, the biggest thing that we can do, particularly with the membership of CIBSE, is consider how we're designing buildings. Just manufacturing products with lower GWP and lower CO2 values isn't necessarily the means to an end. As the interest in heat pumps and the application of heat pumps increases, we need to also look at how we can then reduce the volume of refrigerants we have in our systems.
So what are we going to see at the showroom? What have you got there?
Look, basic range of air source, ground source systems. We also have a range of domestic/commercial heat recovery ventilation systems. Hugely interesting topic with COVID currently at the moment.
Yeah, you bet. Very relevant.
Absolutely. The bushfires earlier in the year motivated a lot of engineers to consider how we then manage incoming air into buildings, filtration, etc. So certainly it's a huge topic, particularly with new releases of things like Green Star homes, Green Star, the evolution of the energy rating schemes. We're seeing an increase in interest in ventilation.
Tom, with the ever-increasing amount of electrification that we're doing in our buildings, we're going to be using more of these heat pump and air conditioning solutions. What's it look like in 10 years' time? Obviously with refrigerant systems and the phase down of those.
The biggest issue that we probably see globally is that the phase down means that systems that we're putting in buildings today that are going to have a shorter lifespan or a life cycle than the building itself are going to be up for changeover or change out, potentially in a period where that same system may not be available in 10 or 15 years. The solution, we believe, potentially lies within chilled and heated water systems in buildings, serviced by water-to-water or air-to-water heat pumps as the plant, providing heating, cooling, hot water to a building that relies on today's trend refrigerant, and at the end of life cycle can be swapped out and replaced with what's on trend in 15 years' time.
So we're looking at being able to maintain the system but change the plant potentially.
Correct. So keeping the water loops in the building, which are not governed by specific refrigerant flows, pressures, gauges, sizes, etc. But we're going to encapsulated systems that can be swapped in, swapped out as the relevant applicable systems become available in the next 30, 40, 50 years.
So, and then for today's building designers, what do you think is the most pressing thing for them to consider when it comes to achieving net zero and looking at the more sustainable approaches? Yeah,
absolutely. I think it's imperative that we start to design our buildings around our HVAC systems, which I'm sure a lot of the membership would prefer to do. But it's about collaboration with the architects in doing so to achieve efficient solutions.